Hello, everyone. My name is Chanel Blackwood, and I'm the marketing manager at AHIA. Welcome and thank you for registering for today's webinar, Leading the Respondent. Can the background information and the format of the choice sets impact responses to a discrete choice experiment? Today's webinar will run for approximately 60 minutes and will be recorded and uploaded onto the AHIA website. Before we begin the webinar today, I just wanted to run through a couple of housekeeping items. If you experience any technical difficulties throughout the duration of today's call, please feel free to type them into the chat box at the bottom of your screen, and I'll be happy to assist. Everyone on the line has been muted except for our speakers. We'll be holding all questions until the end of the session when we'll open for a facilitated Q&A portion of the call. Without further ado, I'm going to pass things over to Yen. Yen, over to you.
Thanks, Chanel. Hello, everyone. Welcome to the Health Preference Research Special Interest Group webinar series. My name is Yan Meng. I'm a research fellow at the Center for Health Policy at the University of Melbourne. Today, I'm delighted to have Alice Yu to give us a talk on how the background information and the format of the choice sets impact responses to DCE. Alice Yu is a research fellow and former PhD student at the Center of Health Economics Research and Evaluation at the University of Technology, Sydney. Her thesis investigated the different ways discrete choice experiments can be presented to the respondents and the impacts it might have on results. This is of particular importance in health, as DCEs can involve health-specific and technical terminologies which may be unfamiliar to the respondents. The talk will last for about 40 minutes with Q&A in the end, so please feel free to leave your comments in the chat box or unmute yourself at the end of the session. And as Chanel mentioned, the session will be recorded. Alice, over to you.
Great, thanks, Yan. Then I'll just share my screen to get started. Can you see that? Okay.
Yes.
I'm assuming. Okay, great. Awesome. Yeah. So thank you so much for joining me today. So in this presentation, I'll be discussing different ways DCEs can be presented to respondents and exploring how information we present in a DCE can impact the responses we obtain. I'll start off by providing a bit of background to this presentation before moving on to discuss some of the ways DCEs have been presented to respondents through a scoping review I conducted. I will then present a case study comparing results from a patient and general population sample, in particular exploring this idea of narrowing the gap between a patient and general population. In particular, investigating whether we can make responses we receive from a general population sample more like a patient sample by providing them with more information. So first, let's take a look at the motivation behind this presentation. So I'm sure it comes as not much of a surprise to this group, but certainly we are seeing more DCEs being published within health economics. They're becoming more popular as a tool to gather information about people's preferences, and these preferences in turn can help to ensure that the development or new health assessments or programs meet the needs or demands of patients. In other words, DCEs can shape and inform important decisions about how we would like healthcare systems to be designed. But if we are indeed going to be making important decisions based on findings from DCEs, then we need to be thinking about the quality of results we're getting. In other words, we want to ensure that DCEs do provide an accurate reflection of people's preferences. And this requires that respondents actually understand that the task they're being asked to do, and that they understand the attributes and levels used in the DCE. And this can be a challenge within health, as often the topic or terminology used may be unfamiliar to respondents. And as such, DCEs in health can often require extra information in order to help respondents understand the task at hand. And when we provide extra information in health DCEs, it's important to think about how to effectively communicate this information. So this requires an understanding of the different ways information can be presented in a DCE. So what are the different ways to present a DCE to respondents? So in order to investigate this question, I conducted a scoping review as part of my PhD. So in order to be included in the review, studies must use a between subjects design. So this is where respondents are split into 2 or more arms, where the DCE seen by the respondent is dependent on arm assignment. So the DCE would be presented slightly differently in some way between the arms. Studies also have to include at least a single attribute with at least 2 levels in a choice set. So this could even be a single option in a choice set where respondents are asked to accept or reject the option. Studies also must either be a peer-reviewed article, a relevant dissertation, or systematic review. And studies were excluded if they didn't use the standard DCE format. So what I mean by that is the respondents in the standard DCE format is presented with 1 or more choice sets, and in each choice set, they're asked to pick 1 option each or to accept or reject it. So studies that used other stated preference techniques, including best worst scaling DCEs, were excluded from this review. In addition, studies where the standard DCE format wasn't the main focus, or the study was a comparison of different stated preference techniques, were also excluded. Pilot studies were also not included if the main study itself was already included in the scoping review and it didn't add any unique information. So just on the left-hand side of this of the slide, I've listed the search terms I used in the scoping review. And just to note, I did include the term conjoint analysis as a DCE search term, and this was done to identify any articles that use the term conjoint analysis but were actually DCEs. A number of databases were searched with a total of 3,714 unique articles identified. And these articles were then screened by title, abstract, and full text, with 69 articles included in the scoping review. So just before we continue to the results of the scoping review, I did want to clarify the terminology I will be using. So when I'm talking about the presentation of a DCE, I am referring to any content that respondents see prior to the choice sets, such as any introductory information, or perhaps a choice scenario, or any context that's given prior to the choice sets, and also includes the way the choice sets itself are presented to respondents in a DCE. So as mentioned earlier, included studies all use a between subjects or a split sample approach. I will be using arms to refer to the groups respondents are split into. So for example, a study could have 2 arms and each arm sees a slightly different version of the DCE. So in such a situation where the DCE presented is dependent on arm assignment, that will be known as a presentation difference in a study. And also to note, there could be more than one type of presentation difference that is used in a study. And hopefully what I mean by types of presentation differences will become more clear as we go through the next few slides. So from the scoping review, there were 3 broad overarching types of presentation differences used. So this included differences in how information or the content of the DCE is presented to respondents in the DCE, either prior or within choice sets. So this could be where the text presented to respondents was different in some way between the arms. It could also be the situation where researchers have chosen to use alternative formats to text, such as pictures or videos, and the formats could be different between arms. So apart from differences in how information is presented to respondents, Researchers also varied the amount of information provided depending on arm assignment. For instance, in a 2-arm study, one arm could receive basic information only in the introductory section, whereas the other arm receives the basic information plus some further explanation about a particular attribute. There was also the situation where the number of options, attributes, or levels presented to respondents were different in each arm. In terms of how frequent each presentation difference type was in the included studies, researchers most often chose to present text in a slightly different way between arms. This was followed by varying the amount of information and then followed by differences in the presentation format by arm. So in the next few slides, I'll go through a couple of examples to illustrate these presentation difference types. So a classic example of a type of difference in text is using positive or negative framing or gain or loss framing. So this example is from 2016. And in this paper, the researchers had 2 arms. One arm where one of the attributes was framed in terms of probability of surviving colorectal cancer. So a positive or gain framing, or probability of dying from colorectal cancer, which is a negative or loss framing. So another example of differences in text was where researchers made use of the anchoring effect. So in the example on this slide, respondents were given slightly different introductory information about muesli as a breakfast cereal. So that was the topic of interest for these researchers. So in the introductory information, they included information about the average amount of sugar in muesli, and this was intentionally set low at 10 grams for some of the arms and set high at 37 grams in other arms. And they were interested to see how this would impact on the choices respondents would make. So studies also frame text by using different terminology to describe an outcome or concept. So in this example, the researchers had 2 arms in their study once again. And in this case, this was a more environmental related paper. So this was investigating ecological indicator choices. So during the development of this study, the researchers conducted some focus groups and interviews. And an outcome of this was that respondents found 2 ecological indicators to provide very similar information. So this is the PVA and migrants attribute, which are highlighted in red on the screen. So the PVA attribute was the probability that migratory species will still be migrating in the river in 50 years. And the migrants attribute was the expected number of fish that will swim upstream each year. And respondents saw either the PVA or migrants attribute depending on arm assignment. So the next most common presentation difference type was the varying the amount of information provided. And in this example, researchers provided one arm with extra information. So all respondents saw the product attributes. So that was the attributes of brand, battery life, control, and price. But the extra attributes of valence, volume, and variance were only seen by the treatment arm. And this was presented in an online customer review star summary table. So studies also presented information in different formats between arms. So this could include the use of pictures, graphs, videos, and even simulated environments. So in this example on the screen, the researchers chose to present choice sets in one arm with still images, which respondents could view as a slideshow. So they would click through to see the attributes. While the other arm was actually shown a 3D film sequence. that respondents would watch. And both arms also saw some additional attributes presented as text at the bottom. So although less frequent, the scoping review also found studies that chose a different number of options, attributes, or levels to present to respondents depending on arm assignment. So this study on the screen by Ullman et al. From 2017. So researchers in this study had a total of 16 arms where they systematically varied the number of options, attributes, and levels presented to respondents. There were also a number of studies where the number of options and the inclusion of an opt-out was dependent on arm assignment as well. So a question to ask as well is in terms of whether differences in how DCs are presented to respondents had an impact on findings. So it was found for the vast majority of studies, some difference was reported according to the analyses from the results section of studies. So only 4 studies found no statistical difference by arm. And as you can see, the study sample sizes for these studies are reasonably large, suggesting that it may not be due to a lack of power. So overall, based on my review, it appears that more often than not, DCEs are sensitive to the way information is presented. So this is what my scoping review found. However, it's also important to consider what other reviews have found. So finding other reviews on this particular topic was surprisingly difficult. But there is one review that was partially relevant from 2016. So this was a systematic review of DCEs published within the environmental economics literature. And the authors were interested in understanding the reliability of DCE results. And this was investigated by looking at whether there were differences in DCE results when the same DCE was presented at 2 points in time to respondents, and also by examining whether DCE results were different when slightly different versions of the DCE were presented to respondents. So in total, 50 studies were identified covering 87 reliability outcome measures, and no statistically significant difference was found for 55% of the included outcome measures. So when considering the results from this systematic review, it should be kept in mind that included studies could use either between or within subject designs, although the majority of studies included were actually between subject designs. In addition, outcomes included not only the impact of differences in presented information, but also temporal stability of results. Findings were also specific to the environmental economics literature. So findings from this systematic review are only partially relevant to the current scoping review. However, the evidence that is presented in this systematic review suggests the potential presence of underreporting of the finding of no difference between arms in the DCE literature as a whole. So overall, what can be concluded from my scoping review findings and from this systematic review is that the impact of presentation differences in a DCE does appear to be mixed. That is, there are instances where small differences in how a DCE is presented have led to significant differences in results. Conversely, there are instances where they have not. So this then leads to an interesting question. If presentation differences in a DCE does not necessarily lead to differences in results, can we actually design DCEs such that the information presented is independent of preferences elicited from respondents? In other words, can we purposely present a DCE slightly differently in one or more arms, but these differences don't actually affect the choices respondents make? And this is one of the questions that we will be exploring in the following case study. So just as a bit of context to this case study, In the health economics literature, there has been debate about whether it is appropriate to use a patient or general population sample in preference studies. And this is a relevant question for about whose values are most relevant for cost utility analyses and economic evaluation more generally. So there is an argument for using general population, particularly when these analyses are used as evidence in decisions about how we allocate public resources. But there also has been arguments that patient samples are more relevant because this population brings with them personal experience or knowledge about the topic and may potentially give better quality responses, or may take the DCE more seriously because there is some kind of personal relevance there. So an assumption behind this debate is that patient and general population samples are different in some way. And indeed, within the literature, there is evidence that there does exist some preference differences between patient and general population samples. So although a meta-analysis in 2006 found no differences in preferences, many other reviews have found that having prior knowledge or experience can influence or affect preferences for attributes and their levels. So this is somewhat problematic from the perspective of health researchers. In many instances, we would like to use patient samples. However, there exist many barriers whereby it's not possible to actually access these samples. For instance, depending on the health topic, it may not be feasible to recruit enough of them in sufficiently large numbers in a reasonable timeframe for a study. It could also be just simply too expensive to recruit a patient sample. And it could even be the case where a relevant patient sample doesn't even exist yet because the research may be for a new health treatment or technology. In contrast, we know that general population samples are generally much easier to recruit, and they can be recruited quickly and at relatively low cost. They can also be useful if we're interested in understanding the preferences of potential patients. But general population samples can't be used as a direct substitute for patient samples. Because, as discussed, due to differences in knowledge and experience, there is evidence that there are preference differences between these two populations, which means answers we get from the general population sample may not be applicable to patient population samples. So a question to ask is, can we somehow make patient and general population samples more alike? Certainly patient samples often have more relevant knowledge or experience. So could providing more information to a general population sample help narrow this gap in knowledge or experience? So this case study really had two aims. Firstly, to investigate whether extra information helps a general population sample understand the DCE better, and whether this extra information can reduce any potential differences, including any preference differences between a patient and general population sample. So these two aims were investigated in the context of a DCE, which sought to understand people's preferences for how chemotherapy-induced peripheral neuropathy, or CIPN, is assessed. So for those that aren't familiar with CIPN, or peripheral neuropathy, it refers to damage to the peripheral nerves, which can lead to a number of symptoms, including the feeling of pins and needles, numbness, or loss of balance, which can mean common activities such as cooking and cleaning are now potentially more hazardous. And there is definitely an increased risk of falling in this population as well. So it's important to recognize that CIPN can worsen as chemotherapy treatment continues. And for some patients, it continues to be present long after they finish their chemotherapy treatment as well. So it has been estimated to affect up to 40% of cancer survivors and definitely has a negative impact on their quality of life. Despite this, there currently actually exist no guidelines for how cancer patients should be assessed for CIPN. And as a result, the aim of this DCE was to understand what features are important to include in an assessment for CIPN. So just on this slide, I've listed the attributes and levels used in this DCE. So the levels in bold were used as the base case for analysis. So the assessment, so the CIPN assessment could ask about symptoms or symptoms impact on usual activities. It could also vary by picking up major nerve damage only, or it could pick up both minor and major nerve damage, whether it's important or not. The CIPN assessment tool could also include a questionnaire ranging from 3 to 20 questions long. It could also include a type of physical test, including a clinician-administered test, patient activity-based test, or a technical test. The CIPN assessment tool could also be completed during usual clinic time, but it could also require additional time ranging from 10 minutes extra all the way to requiring a separate appointment altogether. So the results from the CIPN assessment could also be handled differently. In the base case, the doctor discusses with the patient and together they decide what it means for their care or treatment, so shared decision making. But it could also be the case where the doctor just changes the patient's general care or cancer treatment. So in this DCE, there were 32 choice sets in total. It was a main effects only design and was a generator developed design using code. So it was created in Mathematica using code created by Burgess and augmented by Street. So some restrictions were put into place, such as no questionnaire and no physical test could never appear together, as it doesn't make sense for an assessment tool to include, to not include a survey or a physical test. So for the attributes with just 2 levels, for these attributes, it was held at 1 attribute level in one half of the choice sets and held at the other level for the other half of choice sets. So each respondent was given a block of 8 choice sets to complete, and in each choice set they saw 2 assessment options and they had to choose 1 assessment option in each one. So this DCE involved 2 main studies. So study 1 was the patient sample, and the patient sample was recruited on a volunteer basis. So in the introductory information, these respondents were given some text explanation about what CIPN was, its common symptoms, its potential impacts on their quality of life. And they were also given some text and pictures of what the physical test could look like. And in total, 117 respondents completed this DCE. Study 2 was the general population sample. So respondents were recruited through an online panel with age and gender quotas set to be representative of the Australian population. So there were 2 arms in this study. Arm 1 had 167 respondents and Arm 2 had 168 respondents. So just on this slide, I just wanted to highlight some of the key differences between the arms. So Arm 1 received the same information as the patient sample. The only difference being that Arm 1 saw the information over 9 pages, whereas the patient sample saw the information over 5 pages. So Arm 1 of the general population sample had more of a spacing for the information. So as you can see on the slide, Arm 1 and the patient sample saw pictures of the types of physical tests that could be potentially involved in a CIPN assessment tool. And pictured here is the sharp and dull test and the sway test. So Arm 2 received the same text explanation explaining what CIPN was, its symptoms, etc. But they received moving animations to explain the physical test, as well as a short video. So for the sake of time constraints and to avoid any potential technical difficulties, I won't be playing the video, but basically this video reviewed what CIPN was, its common symptoms, and included patient testimonials of their experience with CIPN. So since we have two arms in the general population sample, which received slightly different type and amount of information, and also a patient sample, it is possible that results from any models we run are not directly comparable between arms or samples due to differences in scale. So the scaled MNL model or SMNL model can be used to test for the presence of scale, and consequently to determine whether model parameters from different populations or arms can be directly compared for analysis. So this works by the inclusion of a scale factor in the utility function, in this case for option J in a given choice set for respondent I. So the SMNL model expresses a particular form of heterogeneity whereby the beta coefficients are all scaled proportionally by sigma I. And this sigma I can be influenced by individual specific factors represented by SI. So for instance, this is where I could put in a dummy variable for arm assignment or population type. And the delta variable represents the vector of parameters associated with SI. So if the associated delta parameter is significant, then this indicates the presence of scale differences either by arm assignment or population type. Models were estimated in RStudio using the GMMNL package. So scale differences were first tested for the general population arms using the SMNL model. So the delta parameter, which is highlighted by the red box on the screen, was not significant at the 5% level. And this indicates that there were no scale differences between arms, which is great, which means they can be combined together for a formal analysis of differences. So a MNL model was estimated with the inclusion of a dummy for arm. However, it turned out there were no significant interaction effects between the attribute parameters and the dummy. In other words, there doesn't seem to be any differences in terms of scale or preferences for attribute parameters by arm. So this finding of no scale or preference differences by arm was quite interesting, considering that ARM2 had been provided some slightly different and additional information. But there was also the question of whether there were differences in other aspects. So after respondents completed the choice sets, they were then asked a series of evaluation questions. So this included some questions where they had to rate on a 5-point Likert scale about the ease of identifying differences between assessment options and the ease of choosing between assessment options. So I ran a chi-square test and also an asymptotic linear by linear association test, which is more sensitive to the linear nature of a Likert scale. And this was done to test for whether there were any differences in responses by arm. And it was found that those in ARM2 were significantly more likely to agree that it was easier to identify differences between the options in the choice sets, although it didn't make it any easier to choose an option within choice sets. In other words, the extra information provided in ARM2 seemed to help respondents understand the attributes and levels without actually influencing preferences exhibited for these attribute parameters. So now taking a look at the patient and general population data. So a SMNL model was run once again to test for any scale differences between these two populations. So the patient sample was used as the base case, with the two general population arms entered as individual variables highlighted by the red box on the screen. So as you can see, the delta parameter associated with arms 1 and 2 were both significant at the 5% level, indicating that there were significant scale differences between the general population arms and the patient sample. But that being said, it was interesting to note that the delta parameter value was quite different for arms 1 and 2. In particular, the delta parameter estimate for arm 1 was twice the size of the delta parameter estimate for arm 2. So even though scale differences were still significant, the extra information provided in arm 2 seemed to have actually reduced this scale difference between a general population and patient sample. So what did we learn from this case study? So it was encouraging to find evidence that the provision of extra information in the form of moving images and a short video did actually significantly improve respondents' understanding of the DCE, and that this improved understanding did not come at the expense of influencing preferences exhibited by respondents. So this case study supports previous literature with the notion of patients and general population samples being different. And this was demonstrated through the significant scale differences detected between the two samples. That being said, there was also evidence that by providing extra information to a general population sample, this can reduce the scale difference with the patient sample. So before we move on to discussing the implications of findings, I did want to point out some potential limitations to what I presented today. So for the scoping review, I didn't undertake a quality assessment of included studies, so quality of studies could vary quite widely. It's important to also note that I only looked at statistical significance and that this is very different from economic significance. There's also the chance that during the data extraction process that I may have unintentionally excluded some studies that may have been relevant during the data extraction process where I excluded by title and abstract. Hence, the included studies may not be exhaustive. So for the case study, it should be noted that the gender and age distribution of the patient sample was very different to the general population sample. The patient sample were all volunteers. They tended to be female and were older on average. In contrast, the general population sample were recruited through an online panel, and they were representative of the Australian population in terms of age and gender. But despite these differences, it's one thing I did want to point out that when I look at the models of best fit for each sample, so due to time constraints, I didn't present it here today, but if you just look at the pattern of preferences for attribute parameters for the patient sample versus the general population sample, the pattern of preferences were actually very similar, with the main difference being that the patient sample thought it was very important to have an assessment that looked at symptoms' impact on usual activities. So there was this concern with the quality of life implications of living with CRPN, whereas the general population sample were very indifferent about this particular attribute. So it was just unfortunate that due to the scale differences, the patient and general population samples couldn't be combined together for a formal analysis of preference differences. And reflecting on the findings from the scoping review, so from the included studies, 3 main types of presentation differences were identified. So this included how information was presented in a DCE, such as the wording of the text or using alternative presentation formats to text, as well as differences in the amount of information provided to respondents and the number of options, attributes, or levels shown to respondents. It's also important to keep in mind that these presentation differences weren't mutually exclusive. There were certainly studies that used more than one type of presentation difference. So one thing I think to highlight was the difficulty I had in identifying relevant studies. Often there would be no indication in the title or the abstract or the keywords that the study was using a between subjects design, or we're even looking at presentation differences and how this may impact people's responses. So I spent a lot of time reading the actual text of the studies, particularly the methods section. So for the sake of future reviews in this area, I would highly encourage researchers to use keywords in the keyword section, in the title or abstract that gives some kind of indication. I mean, I've chosen to use the umbrella term presentation difference here, but I am aware that this is not widely used. It was just something, a term that I used to help me structure the scoping review. But there are definitely more commonly understood terms that can be used, such as between subjects design, split sample approach, even including the word of presentation, amount of information, structure of choice sets. This would already be very helpful. It would also be very useful for health researchers to understand further where when presentation differences doesn't have an impact on preferences elicited. So future research in this area is also highly encouraged. So the case study I feel is something that will be relevant to a lot of DCE health researchers. There are many instances where extra information needs to be provided to explain unfamiliar terminology to respondents and to ensure that respondents actually understand the choice sets. So the intention for a lot of the times is to improve understanding and not necessarily to influence people's preferences or choices. And this case study gives evidence that it is possible to actually design studies this way. And in terms of whether providing extra information brought a general population sample, a sample closer to a patient's sample, an interesting finding was that the extra information did reduce scale differences between a patient and general population sample. And a future direction of research could be to investigate whether more information could have reduced the scale difference enough that or mitigate it entirely so that model results from these two populations could be directly compared for analysis. But even if this is possible, it must be acknowledged that preference differences may just still exist between patient and general population samples, but it would definitely be interesting to see how often and in what situations this is the case. So last but not least, so the work I presented to you today was from my PhD, and this wouldn't have been possible without the advice and guidance from my supervisors, Debbie, Rosalie, and Stephen, as well as the support from fellow PhD students and colleagues at SHARE. And I'd also like to acknowledge the Australian Government Scholarship and UTS Chancellor's Research Scholarship for funding my PhD. So thank you so much for listening. I'll now stop sharing my screen and open it up to some questions.
Thank you, Alice. That was really interesting. I learned a lot from the scoping review and your DCE case study. Any questions from the audience? If you'd like to provide any comments or have any questions, please feel free to talk or type your questions, and I'm happy to read it out. Well, okay, here we have a question. Can you see it, Alice?
Yeah, so the question is, how great was, oh, sorry, too many people. Okay, how great was SMNL in addressing scale heterogeneity? So SMNL is used just to detect the presence of scale heterogeneity. It's not really solving or addressing scale heterogeneity, so to speak. So if there is the present, so it just tells you whether or not scale differences are present. So if as you could see for the general population sample, it wasn't present, so I could combine the data for analysis. But because the SMNL model did show some significant scale differences, I couldn't combine the patient and general population sample for analysis.
Great. And we also have a question from Allison. Great presentation, thanks. In your review, given the majority of studies found a significant difference by presentation, how did they manage that in their analysis and interpreting of results? Did they do an scale MNL or just combine arms, or have to present results by arm?
Yeah, so I think one thing to point out was that in a lot of studies, there generally was a situation where they could somehow get rid of the scale by using marginal rates of substitution. So this is where willingness to pay was very common in a lot of the studies that were included in my scoping review. So this is where the scale difference can be cancelled out and it can be interpreted for analysis. So I didn't really see that many that use the SMNL model. There were definitely some, but not that many, unfortunately. Yeah, and I guess part of this presentation, part of my PhD was trying to figure out a way to sort of reduce the scale difference in a situation where we can't use marginal rates of substitution or calculate willingness to pay in order to interpret the results.
I hope that answers your question, Allison. And we also have a comment from Rebecca. Okay, Allison has a follow-up question.
Yep.
Yeah. I haven't done SMNL before, so just wondering, given you found no scale difference between arms in the GP sample, can you say that the difference in the delta scoring in the SMNL is significant, or is it simply a trend?
So are you referring to, so there were two models I presented. So it sounds like you may be asking about one of them, but I'm not too sure which one you're asking. Do you mind just clarifying, Alison? Oh, okay, sure.
Yeah, it was just a comment from Rebecca. Very interesting presentation. Thank you. I might just chip in the question for now. I know at the end of your design, you had an evaluation question to assess their understanding. Do you have other indicators to assess that?
No, it was just so I think, do you mean like including some like internal validity check in the in the choice sets?
Yeah, that's one of them. I was also wondering, say, whether the response rate might say something, because these topics might be more relevant to part of the participants, but not the other half. And that will also affect their understanding.
Yeah, so I didn't include any internal validity checks, if that's what you're asking. And in terms of relevance, I mean, the actual pattern of attribute, like the preferences for the attribute parameters were actually very similar. So there weren't actually that much difference, even though when it's, you would think that a patient sample would have very different preferences to the general population sample, but that's not actually what I found. So I don't feel like the personal relevance is as big of a factor as sometimes people make it out to be. Yeah. And I think for the online panel, there may be some incentive to actually take it seriously, because they're being paid for their responses. So, they won't get paid if they don't, if they completed it at a really short time frame, or, the responses don't make any sense, then they won't get paid. And certainly when I was analyzing the data, I don't think there were that many that gave nonsensical responses. I think there were definitely like 5 or 6 I had to exclude because it looked like it was a robot completing them. But that was about it. Yeah.
Cool, thank you. But let's just say in your patient and public sample, you do find differences in results. Then how do you tease out the effects from the presentation and conclude it's actually not their true preference difference?
So if there was no scale differences, then you could run the MNL model with a dummy for the and for the patient. So you would identify, the parameter, so you maybe use the base case would be the patient sample, and all the results will be in terms of comparing against the patient sample. So the interaction with the dummy would tell you the preference differences it may have with the patient sample and whether it was significant. So that way you could identify whether, I don't know, arm 2, for instance, had more similar preferences to the patient sample, for instance, or I don't know, it could even just be that there was just fundamental differences, in which case it may still be, there may be significant differences still.
Right, okay, yeah. Let's move to Allison's follow-up question. You found no significant scale difference between the 2 general population arms, but then suggest that the different size of the data seen between the 2 general population arms when comparing general population to patient sample suggests the extra information reduced the scale difference. Can you say the reduction in scale difference was significant?
Yeah, that's an interesting question. I'm not too sure because I didn't formally test, and I'm not too sure what test I would use to test for whether this scale difference was significant. Yeah, I think because I was just comparing the absolute values of, so yeah, in the presentation, I was just comparing the absolute values of the delta parameters. I didn't actually run any formal tests, although if you have a suggestion for a test I could run to test for whether it was significant or not, I'm definitely open to that. Yeah.
Thank you. Any other questions? Yeah, there's one more comments. Yeah.
Yeah, no, definitely. Yeah, I mean, when you do write it out, it is obviously important to point out that we are just talking about the absolute values. I didn't actually test it for significant difference, and I don't suggest that it was significantly different in that way.
So for your patient sample and your arm 1, you mentioned it's just really just the change in spacing in presenting the information. Is that the case? What was the rationale behind that?
Yeah, so the patient sample we used, so in order to be included, they had to have had experience with, had cancer, and they had to have gone through chemotherapy treatment. So they would already have a lot of knowledge about this kind of thing. So in that case, the information, we just put it across 5 pages. But when I was designing the arms for the general population sample, I did think about, you did have to scroll a bit for some of the information. And in order to make it easier, and there was also the issue of whether it was going to be too much information if we did put it all in one page, like whether they would actually scroll through the whole thing. So I did want to make it so it's literally, you just look at the information and you click next to view the next part. So yeah, that was sort of the reasoning, just to make it easier.
Okay, yeah. Any more questions from the audience? No? Just feel free to type it in, and I have one more question for Alice. Did you pilot your DCE?
Yes. So before we launched, I did do some cognitive interviews to sort of workshop the attributes and the levels we used, and it did actually change quite a bit before and then I did some just some informal piloting just within my research center, just to send it around and ask for feedback. But yeah, I think the most significant part was the cognitive interviews with 6 breast cancer patients. And because the patient sample was actually part of a larger study on CIPM. So we had clinician input as well on that. Yeah.
Awesome. Yeah. If there are no more questions, that brings us to almost the end of 1 hour. I want to thank you again, Alice, to give us such an interesting talk. I learned a lot, especially seeing more DCs using videos and images nowadays to, help people understand. Awesome. So just to note that we have the next seminar series so the next speaker will be John Buckle, which is on the 12th of July. And we also have a series of ECR seminars scheduled all the way till the end of the year, monthly webinars. So I hope to see you all there, and stay tuned. Thanks, everyone. Hope you enjoy the rest of your day.